Hello students, today's class will be exactly continuation of the last class. Last class we have stopped here. In this particular problem we have found capacitance in the last class between A and D. This one we have already done it. Okay. Now if A and D, if it is not given, if we have to find capacitance between this B and E or capacitance between C and F. This particular circuit, every capacitance is C. Every capacitance is C. Let me call this point to be something different. Z, for example, Z. Z and F. We have to find capacitance between Z and F. Each capacitance has magnitude C. So this is a symmetry circuit, has some kind of symmetry in the circuit. We will have to solve this particular problem by finding different points having same potential. Okay, so you see my last lectures, I have already solved it. We have found equivalent capacitance between point A and point D. So now we are going to solve how to find equivalent capacitance between Z and F, right? So between Z and F, these two particular points. Now see between Z and F. Okay, so from Z, for example, if I connect a external EMF here, battery here, so how the charge will flow? Charge is entering here, it will get divided into three parts. So you see, while going, it is entering to this one, and this one. This is how the charge is entering. So this is will go directly. If I call this is Q1, this is Q2, and this is Q3. Okay, at the time of entering, what is the symmetry? At the time of going out, the symmetry is going to be the same, because the entrance and the exit are exactly same. Okay, this one is going, so this way how much charge will go out? Q2, Q1 is here, and from this side finally again who will come here? Q3 will be coming from this side. Okay, so the charge, the way it was getting distributed in an identical manner, it got reunited. And if the total charge is Q, where Q is equal to Q1 plus Q2 plus Q3, similarly Q1 plus Q2 plus Q3, total charge coming out also will become equal to Q. Okay, this is how the charge will get distributed. Okay, let us okay, now from here let us understand something. Okay, we are not interested with the distribution of charge at this moment, but we are just trying to understand some kind of symmetry in the circuit. Okay, now so here you see one thing, the charge Q2 which was going here will be coming back. Charge Q3 will go here, will get divided into two parts. For example, this side is Q4, then this side will become how much? Q3 minus Q4. Q3 minus Q4. This Q4 will go. This side is how much going? Q3 minus Q4. Again the charge here will have to be how much? Q3. So from this side what is going? Q2 minus Q4 is going. Q2 minus Q4. So how much will have to come from this side? Q4 will have to come. Then only both will add up and will give you Q3. That means this particular charge which is going Q4 going up is coming down. This Q2 which is going up this way and coming down. So what you have seen? Have you seen any charge from Q4 going to that side, or any charge from Q4 going to that side, or any charge from Q2 going to that side? No, not going. So Q2 is going up, coming down. Q4 is going up, coming down. In this particular arm, no charge is flowing. So this particular capacitor can be neglected. If you have understood this way, well and good. If you have not understood, then let me show you one more picture. I'm going to go very slowly. You have to understand this. Between Z and F, okay, D is exactly the midpoint. Similarly, this way, between Z and F, if you go this way, one C, another, next, this way if you go, you will find point A is exactly the midpoint between Z and F. And this particular part, that side, this side, that side, there's some kind of symmetry. These are all CC. Had it been 5 microfarad, this is 6 microfarad, then the picture would have been different. Now this is also C, that is also C. This is also C, this is also C. This part and that part, this part and that part is exactly identical. So you can see between Z and F, D is exactly the midpoint, and between Z and this way, F here, A is exactly going to be the midpoint. So if you connect a battery out here of 10 volt, this is, I'm calling this potential here to be 10 volt and potential here to be 0 volt, then D will be having a potential of 5 volt because it is a midpoint. Similarly here, A is going to have a potential of 5 volt. This is a midpoint. So between A and D, A is also at a potential of 5 volt, D is also at a potential of 5 volt. So from A to D, no charge is going to flow. Okay, neither from D to A. So that is why this particular capacitor can be neglected. This particular capacitor can be neglected. So in this circuit, when we have to find equivalent capacitance, between Z and F, between these 2 points, this particular capacitor will get neglected. So if it is getting neglected between Z and F, you see this is Z, this is one capacitor, Z and F. Okay, on the upper side, this side is how much? Twice C and C, C by 2, C and C, C by 2. This is C, these two equivalent is what? C by 2. And on this side you see is first coming capacitance C, then in this particular part 2 are in series, then in parallel with the third. Its equivalent I have already shown you. C and C, let me show you this way. This is one, this is another capacitance C, then from E to F, this is another, this is E, this is B, and this way from B to E, C and C in series, so equivalent will become C by 2. This is C, C and C. We have to find equivalent capacitance between Z and F. So this circuit will give us how much? C and C by 2 in parallel will give us 3C by 2. Between G and F, these two are in parallel. So I'm adding them, C plus C by 2, 3C by 2. Check out this way, C by 2 and C, they are in parallel. So equivalent will become how much? 3C by 2. So there is a capacitance C, there is a capacitance 3C by 2, again there is a capacitance C. So between these 2 points, these 3 are in series, then in parallel with this one. So how much you are getting from here? Below, between Z and F, below how much? 3C by 2, and above how much will get in series? 1 by C1. Let me call the equivalent is C1, then 1 by C1 is equal to 1 by C plus 1 by C plus 2 by 3C. If you take 3C LCM, 3 plus 3, 6 plus 2, 8. So C1 is equal to 3C by 8. So on this side, how much is coming? 3C by 8. Now they are in parallel. So equivalent will become, add them, 3C by 2 plus 3C by 8. 8 is the LCM. 4 3 is 12. 12 plus 3, 15. That's it? 8. 4 3 is 12. Plus 3, 15. This is how we can solve it. अब Q वाला प्रॉब्लम ट्राई करो, Q वाला प्रॉब्लम मैं एक दिखा दूंगा. Q वाला प्रॉब्लम, दिस इज अ Q. A, B, C, D, E, F, G, H. Each arm contains one capacitance. Each arm contains a capacitance of C. Each arm has a capacitor. Okay, C. We have to find equivalent capacitance between which 2 points? Across one side We can find it three ways. Across one side, that is between AB or between BF or between AE, across a side. CAB, how much? Number two, across a face diagonal. This is one of the faces. So face diagonal. What is the equivalent capacitance between A and F? CAF. Across a body diagonal. Body diagonal going from one corner to the other corner. Okay. Between B and H, equivalent capacitance. Between B and H, or between A and Z, or between D and F, or between Z and E. So we'll find out between C and E. Okay. So equivalent capacitance between A and G. These three capacitance we have to find. So out of that, I'll be showing one, two, you try yourself. Okay. So let me find out equivalent capacitance between A and B. Equivalent capacitance between A and B. Okay. So the circuit is symmetric because every arm has identical capacitors, each of magnitude C. So equivalent capacitance between A and B. Equivalent capacitance between A and B. So if you imagine, if I connect a battery here, the charge which is entering is going to get divided like this. Q1, Q2, Q3. The charge which is going out, okay, will go. You see how the charge will flow. This one too will come directly, will come out, will pass through this capacitor. Okay. Now see these two parts. They are same part or they are different part? Exactly same part or different part? For that, let me take a box. Wait, I have got a box. Good night. I have got a box. This is the cube. So we want to find equivalent capacitance between these 2 points. Between these 2 points. I'm connecting a battery. So a certain amount of charge will go directly from one side to the other side. Okay. And one side is this way. Will get divided into 2 parts. Come back. The other one is from this side. One is going directly, one is this way, one is this. If this is a cube, then you need to understand this particular path and this particular path. Through which path more charge will flow? If I ask you that, then you will tell me, so this particular path, the way the charge is moving, so these 2 paths are should be exactly same. Okay, though their positions are different, but they are exactly identical with respect to each other. Okay, so a certain amount of charge will go this way, this charge will go, this charge will go. These 2 paths are going to be exactly identical. See now, if you go this particular path and this particular path, and a box you can understand between these 2 points, I am connecting the battery, this part and this path, these 2 paths, this particular path and this particular path, they are completely identical. So that is why point D and point E are identical points. Similarly, point C and point F are identical points. So potential at D should become equal to potential at E, and potential at C should become equal to potential at F. So these points can be joined. This one point, because this particular path and this particular path are exactly same path. Okay, so this point and this point should be having same potential, this point and this point should be having same potential. If that is a scenario, so I can join these 2 points. These 2 points can be just joined because having same potential. These 2 points can be joined because they're having same potential. Then how the picture would look like? Between A and B, one capacitance is there. Capacitance of C. I'm going to join D and E. I'm going to join D and E. Wait a minute. I'm going to join, this is A, B. I'm going to join D and E. D and E I'm going to join. So A, D, A, E. A, D, A, E. 2 capacitors. Each of capacitance C. Okay. And that upper point is what? H. D, H, E, H. 2 points. D, H, E, H. Again 2 capacitors. So from this side I am going to join C and F. B, C, B, F. B, C, B, F. This is C and F. Then C, Z, F, Z. C, Z, F, Z. Two capacitors. Now between H and Z, there is a capacitor. Between E and F, where is E? E is here. Where is F? F is there. Between E and F, there is a capacitor. Again, between D and C, there is a capacitor. Between D is here, C is here. Capacitors. How many come? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12 capacitor. So this is the final circuit. So now you know how to find out the equivalent capacitance. Parallel, parallel, series, parallel. Okay. So let me take it there. Twice C and C in parallel, twice C. Okay. And these three are in series. You find out the equivalent of these three. How much you'll get? C by 2. How much I'll get? C by 2. Let me do it once again. Twice C. That is C. This side is twice C. In between twice C. Twice C. Twice C. This is C. Now these three are in series. Twice C in series. C and C in series. C by 2. So at the top we'll be getting C by 2. C by 2. And again C by 2 is in parallel with twice C. Clear? Then this is twice C. We have to wait. Going to be little lengthy. This is twice C. This is twice C. Now C by 2 and twice C, they are in parallel. So on the top arm, equivalent capacitance will become C by 2 plus twice C. 4 plus 1, 5 C by 2. 5 C by 2. Yes, correct. These two are twice C and twice C. Now this capacitance is 5 C by 3. So see what will happen in the next line. Twice C and this one are in series. So twice C and twice C in series equivalent is C. So C and 5 C by 2 are in. So let me do it directly. Let me call this equivalent is C1. So 1 by C1 is equal to 1 by twice C, 1 by twice C, 2 by 5 C. Let me take 10 C LCM. 5 plus 5, 10. 10 plus 4, 14. So C1 will become 5 C by 7. Okay. So how much we are getting finally? We are getting two capacitance. One on the top, one below. This is C, and that is coming out to be 5 C by 7. So finally CAB will become how much? Sum of these two. C plus 5 C by 7. 7 plus 5 is 12 C by 7. This is the equivalent capacitance across A and B. Similarly, you try between A and F. When you go from A to F, okay, so you'll find C and H to be having same potentials. Try to figure it out between these 2 points. C and H and B and E will be same potential between these two. Whether you go this way or go that way, these 2 points will be having same potential, they can be joined. Or between A and F, this point and this point will have same potential, they can be joined. Okay, you try it out.